You may have died 5 minutes ago, perhaps in a fleeting instant, a blink that escaped your notice, yet your brain, that intricate physical machine operating at this very moment, persists in replaying the final memories, a brief film looped endlessly on the screen of consciousness, convincing you that you remain within a seamless flow of time. This is not a conventional horror tale of ghosts or life beyond death, but a logical consequence, however outlandish it may seem, of one of the most foundational and contentious scientific theories of the 20th century, the many worlds interpretation, also known as quantum immortality. Envision once more that moment when the lorry veers out of control and hurtles towards you, the blare of its horn tearing through the air, or that fateful instant when you first feel the sharp pang of a terminal illness forewarned by physicians. In the classical physical world we perceive daily, the outcome is singular, life or death, existence or oblivion. Yet quantum physicists, those who delve into the minutest constituents of reality, the fundamental particles that compose our existence, propose an entirely different panorama. They contend that across innumerable parallel universes, alternative versions of you have indeed confronted the direst endings, versions that have succumbed beneath the lorry's wheels or yielded to cancerous cells. And the reason you are still perusing these words, the reason you retain awareness to perceive your own being, is not some miracle of random fortune, but a prerequisite imposed by quantum mechanics itself. Consciousness can only endure and register in those branches of reality where you survive. You cannot perceive death, cannot have a subjective experience of your own vanishing. From your vantage point, you will only register a continuous sequence of narrow escapes, moments where the universe appears orchestrated to guide you through the safe portal, time after time. But in a vaster reality, an assemblage of universes nearly infinite, other versions of you have departed the game forever. This notion, at first hearing, might seem the product of an overactive imagination, a blend of science fiction and metaphysical philosophy. Nevertheless, it stems from a serious endeavor to resolve the profoundest paradoxes in quantum mechanics. We must journey back in time, to the year 1957, to Princeton University, where a young man of merely 27 years, named Hugh Everett III, presented an idea that shook the foundations of physics in his era. Everett, with extraordinary audacity and intuition, proposed the many worlds interpretation, abbreviated as MWI, as a solution to the quantum measurement problem. He believed that, rather than the wave function of a quantum system collapsing into a single definite state upon observation, a process that even Albert Einstein found disconcerting, prompting him to question whether the moon exists when unobserved, every quantum possibility becomes actualized. Each time a measurement occurs, or any interaction transpires, the universe branches into parallel strands, each representing one possible outcome of that measurement. Crucially, our consciousness, itself a complex physical system, branches along with the universe. Everett, with astonishing self-assurance, seemed to imply that he would live eternally, for at each branching, his consciousness would only persist on those strands where he did not perish. Recent surveys underscore the evolving acceptance of this view. For instance, a comprehensive poll conducted by the journal Nature in the year 2025, involving over 1,100 researchers, revealed that 15% of physicists now favor the many worlds interpretation, a notable rise from earlier decades, highlighting its growing traction amid ongoing debates about quantum foundations. This shift is partly driven by advancements in quantum computing, where experiments in 2025 have demonstrated that the wave function is not merely a mathematical tool but a tangible entity, lending empirical weight to interpretations like MWI that treat it as real. The reaction from the scientific community at the time was chilly and somewhat hostile. Rather than being lauded for his theoretical breakthrough, Everett faced ridicule. His thesis advisor reportedly deemed him mad. Colleagues dismissed the idea as a philosophical jest unworthy of experimental physics. Even Niels Bohr, one of the grand architects of quantum mechanics who championed the traditional Copenhagen interpretation, declined to meet Everett for discussion. Isolated and disheartened, Everett abandoned academia, a profound irony for a theory of such far-reaching influence in later years, and pivoted to defense work, a realm seemingly more grounded than parallel universes. He died suddenly in 1982 from a heart attack, at the age of 51. Yet fate appeared to grant him a dramatic and sweet retribution. Merely 2 decades after his passing, his many worlds interpretation gradually gained acceptance among leading physicists, not for its aesthetic or philosophical appeal, but because it elegantly resolves mathematical and theoretical issues compared to rival interpretations. It eliminates the need for a mysterious wave function collapse, replacing it with a continuous evolution governed by the Schrödinger equation. If his theory holds true, there must surely be a universe where Hugh Everett lived to 100, hail and witnessing the full glory of the theory for which he was mocked in life. To truly grasp the systematic madness of this theory, we must delve into the most iconic thought experiment illustrating universe branching, quantum roulette, an idea presented by the brilliant physicist Max Tegmark of the Massachusetts Institute of Technology in 1998. Imagine a roulette wheel not spun by friction or conventional mechanics, but by a quantum state of a particle, such as the spin of an electron. In a quantum superposition, this particle exists simultaneously in both states, let us say spin up and spin down, with a 50% probability for each. You wager your entire fortune on this outcome. If the particle spins up, you lose everything; if down, you double your stake. According to classical logic, after the first spin, the result is one or the other. But in quantum mechanics, before you perform the act of observation, an act here tied directly to your fate, the particle resides in a superposition of up and down. Your observation does not merely reveal the state, it compels reality to split. The universe branches into 2 strands instantaneously. In one strand, the particle spins up, you lose, and according to MWI, your consciousness persists in the other. In the second strand, the particle spins down, you win handsomely, and your consciousness continues to experience that victory. If you repeat this game 100 times in succession, from an external observer's perspective, the probability of you winning all 100 consecutively is astronomically minuscule, 1 in 2 to the power of 100, smaller than 1 in a nonillion. Yet from your subjective viewpoint, as the player immersed in the process, you will experience a flawless streak of 100 victories. You might not merely deem yourself lucky, but perhaps believe you are favored by the universe, probabilistic miracle incarnate. The harsh truth, as Tegmark posits, is that you are not fortunate. Your consciousness is simply ensnared on the soul world line where you never forfeit entirely. A nonillion other versions of you have endured 100 consecutive losses and vanished from your experience, for their consciousnesses have been severed from that timeline. Recent philosophical analyses, such as Mark William O'Brien's paper from 2025 titled The Costs of Rejecting Quantum Immortality, argue that dismissing this implication carries intellectual penalties, as it forces one to grapple with inconsistencies in quantum probability and observer selection effects, further deepening the theory's appeal among those exploring the boundaries of reality. This is the core logic of quantum immortality. The survival of consciousness is assured through the ceaseless branching of reality. Every quantum event with multiple outcomes serves as a divergence point. When you confront a life or death peril, whether a simple decision or an unforeseen accident, your consciousness does not select a path, rather, reality generates all paths, and your consciousness can only experience the path where it persists. Yet even Tegmark, who popularized this thought experiment, later wrestled with its implications. In 2014, he refined his stance, acknowledging that death in MWI might not be an instantaneous on-off switch as commonly imagined. He suggested that death could be a gradual fading, dimming of quantum states, and thus quantum immortality in Everett's literal sense might not hold. Additional research in 2025, such as a commentary reimagining quantum immortality through scientific lenses, posits that while consciousness might persist in some form, it could manifest as fragmented, side-lives, rather than eternal continuity, incorporating insights from quantum computing simulations that model branching more probabilistically. To comprehend why this theory exerts such potent allure, we must return to the origins of quantum weirdness, the renowned double-slit experiment, first convincingly performed in 1927. When scientists fire fundamental particles, such as electrons, through a barrier with 2 narrow slits, and place no detectors to determine which slit the particle traverses, the result on the receiving screen is not two bright bands corresponding to the slits, but a complex interference pattern, akin to what ensues when two water waves meet and diffract. This implies that, prior to observation, a single electron did not pass through the first slit, nor the second. It traversed both simultaneously, existing in a superposition of paths. But the true marvel unfolds when researchers install detectors at the slits to ascertain the electron's chosen route. Instantly, the interference pattern vanishes, replaced by two distinct bands, identical to firing tiny pellets through two apertures. The particle seems to know it is being watched and behaves classically, selecting a single path. Even when electrons are fired one at a time, separated by seconds, to eliminate mutual interaction, the interference pattern emerges, confirming that a solitary particle interferes with itself, having passed through both slits at once. This leads to a conclusion that upends our intuition. Before observation, the particle exists as a superposition of all its possible states. Observation is not recording a pre-existing reality, but compelling reality to choose a single definite state. This is the juncture where Einstein felt profound unease. He could not accept a universe where reality hinges on the observer's whim. He famously queried, "When no one looks, does the moon remain there?" The response from quantum mechanics, at least per the Copenhagen interpretation, is uncertain. Without measurement, no definite reality. To illustrate this absurdity, Erwin Schrödinger devised his famous cat experiment. He proposed sealing a cat in a box with a mechanism triggered by the decay of a radioactive atom. If the atom decays, poison gas releases and the cat dies. If not, the cat lives. According to quantum logic applied to this macroscopic system, before the box opens, the cat exists in a superposition of alive and dead. Who has ever seen a creature both living and deceased? And this is where Hugh Everett entered with an even bolder retort. He disagreed that the cat is both alive and dead in the same universe. Instead, Everett asserted that upon opening the box, the universe splits into two wholly separate branches, incapable of communication. In one universe, you behold the cat alive; in the other, an alternate you witnesses the cat dead. Both outcomes genuinely occur, merely in distinct realities. The absurdity of macroscopic superposition is transmuted into the ceaseless branching of reality. The acceptance of Everett's theory, though gradual, has been propelled by other thought experiments, such as John Archibald Wheeler's. Imagine a photon traversing interstellar space for billions of years, passing galaxies and nebulae. Suppose, just as the photon nears Earth, scientists decide to perform a measurement selecting its path. Astonishingly, the outcome of the scientist's present measurement seems to determine the route the photon took billions of years prior. In the quantum realm, the linear one-way timeline, where cause precedes effect, is utterly shattered. Causality, a pillar of classical physics, becomes blurred and alarmingly flexible. Returning to questions of consciousness and immortality. If every quantum possibility actualizes, then each choice you make, from opting for coffee over tea in the morning to turning left or right on the road, spawns a new bifurcation in the tree of reality. You, the subjective self experiencing this moment, but one among countless, yous, existing on divergent branches of this tree. In one universe, you are a renowned scientist, in another, a wandering artist. And most crucially, in myriad universes, you have faced life-threatening situations. The lorry barrels towards you. The terminal disease erupts. In those branches, versions of you have died. But your consciousness, the recorder of experience, cannot follow those lethal paths. It is compelled to proceed on the branch where physical conditions sustain life and awareness. This is quantum immortality in its literal sense, the impossibility of perceiving death. You do not conquer death, you simply never experience it from your own perspective. Each narrow escape is not random luck, but the automatic continuation of consciousness on the sole viable branch. In 2025, preliminary research from advanced quantum simulation laboratories such as collaborative projects between the Massachusetts Institute of Technology and the Copenhagen Institute for Theoretical Physics, has unveiled an even more chilling facet of this hypothesis. By monitoring neural activity in individuals who endured severe near-death experiences, those whose hearts ceased beating for several minutes before successful resuscitation, scientists have detected traces of quantum states exhibiting branch-like jumps in their brain function. Though fiercely debated, some researchers hypothesize that these individuals did not merely luck out in surviving a physical mishap, rather, at the moment of biological death in the original universe, their consciousness truly leapt to a parallel branch where their body remained functional, if only temporarily. They may have undergone millions of micro-deaths in those instants across diverse universes, but memories of those deaths are utterly erased, for the deceased versions lack any physical mechanism to store or transmit information. Versions that perished in car crashes, drowned in floods, or burned in horrific fires, all those terrifying experiences lie forever beyond your access. Furthermore, innovations in quantum functional magnetic resonance imaging, or quantum fMRI, as explored in studies from Stanford University in 2024 and extended in 2025, reveal that at the most fundamental level of neural activity, an individual's consciousness may exist in microquantum superpositions at certain moments before stabilizing into a singular experience. This suggests that, at any instant, you might simultaneously inhabit multiple consciousness configurations, with internal observation, self-awareness, forcing them to coalesce into the self you recognize. Such findings, bolstered by quantum neural networks applied to magnetic resonance imaging data, offer tentative evidence that consciousness operates on quantum principles, potentially validating aspects of quantum immortality by showing how brain states could branch and persist. It sounds like a blessing, an escape from humanity's primal fear. But consider the cost of this immortality. Quantum immortality guarantees neither a good life, nor happiness, nor even quality. It assures only the persistence of perception. Imagine the horrific scenario: you survive a fatal car accident, not because you swerved in time, but because your consciousness jumps to a rare branch where the collision inflicts less damage, yet you are left paralyzed from the neck down forever. You live, you perceive, but trapped in an immobile body, a prisoner in your own biological shell, eternally enduring absolute helplessness. Or, you overcome late-stage cancer, but only through decades of excruciating chemotherapy, radiotherapy, and relentless recurring pain. You survive, but at the price of ceaseless bodily devastation. And then comes old age. As the body deteriorates, organs fail according to biological laws. In classical physics, this is the natural terminus. But per MWI and quantum immortality, when your heart stops in this universe, your consciousness instantly seeks the next viable branch. You might survive a first heart attack, only to face a second, third, and fourth in ensuing years, each miraculously resuscitated, but each revival weakening your body further. You never die literally, but you are eternally ensnared in a sequence of pending deaths, an interminable senescence where you perpetually experience death's proximity without ever achieving release. This is the curse of quantum immortality, eternally aging, eternally suffering, but never attaining cessation. Another philosophical query arises: if I persist, why do my loved ones die in my universe? The answer is cruel and isolating. When you observe an event, especially one involving another's consciousness, the wave function of your experienced reality collapses into a single definite state. When you witness a loved one's passing, in your universe, they have truly died. Their consciousness has branched to other strands where they live, or ceased entirely if no viable branch exists for them. But you, with your consciousness, can only continue on the path where you survive and behold that loss. You cannot see the version of you in another universe strolling through the park with that loved one. Each stream of consciousness is a solitary voyage through the tree of reality, locked solely into outcomes favoring its own survival. This prompts a deeper examination of the self's nature. Are you truly a singular entity, a continuous stream of consciousness from past to future? In 2024, advanced quantum fMRI research at institutions like Stanford University yielded shocking data. They discovered that, at the most basic level of neural activity, an individual's consciousness can exist in micro-quantum superpositions at certain points, before settling into a unified experience. This means that, at any moment, you may simultaneously exist under multiple consciousness configurations, and only the act of internal observation, self-awareness, compels them to merge into the ego you identify. You believe you are yesterday's person, but at the quantum level, you are an ensemble of possibilities, ceaselessly branching and recombining. Recent extensions in 2025, including the development of the world's first mobile quantum brain scanner for assessing blast exposure effects on brain function, suggest that such quantum states could be directly measurable, potentially revolutionizing our understanding of how consciousness navigates branching realities. Each trivial decision you make today has spawned countless new universes. You choose the blue shirt, in another, the red. You send that email, in another, you delay it. Since you began reading this article, millions of reality branches have arisen merely because you opted to continue rather than return to scrolling social media. There are versions of you who became billionaires through a minor investment opportunity this version overlooked. There are versions imprisoned for a misdeed this version evaded via a slight change in choice. And yes, countless versions have died, forever excised from your experience. You are tethered to your own safety line, compelled to experience the event chain leading to continuous survival. However, even quantum immortality is not an eternal guarantee. Physics also imposes an insurmountable limit on everything in the universe, the second law of thermodynamics. Everett's immortality is merely a deferral of the end. As the universe evolves further, beyond the so-called degenerate era, after a terrifying span of about 10 to the power of 100 years, all stars have extinguished, black holes have evaporated via Hawking radiation, and the universe reaches ultimate thermal equilibrium, a frigid, dark state with temperature approaching absolute zero. At that juncture, no energy sources remain, no material structures complex enough to sustain any form of consciousness, quantum or classical. No matter how many universe branches your consciousness leaps to evade death, ultimately, all those branches converge on that final chill. Quantum immortality is an endless race against personal demise, but impotent against the decay of spacetime itself. So, returning to the initial query, did death 5 minutes ago truly occur? From the perspective of Hugh Everett and staunch adherents of MWI, the answer is yes, it did. But it transpired in a parallel universe, a branch of reality that diverged at the perilous moment. You did not triumph over fate, you are simply never permitted to experience that conclusion. Those versions of you have died, their stories ending in absolute silence, for no surviving entity remains to recount the tale of that death. You are still here, still reading these words, your brain still processing information, still forming critical thoughts about these outlandish theories. This very ongoing act is irrefutable proof that, on the world line you are experiencing, you persist. But what of the millions of other versions of you at this precise instant? What are they doing? Loving, grieving, building, destroying, or facing their own ends? You will never know, and perhaps that is the greatest philosophical burden quantum immortality imposes upon us, the absolute solitude of consciousness trapped in the victorious branch, forever unable to connect, communicate, or even glimpse the paths it might have taken, the people it might have become. The price of immortality is eternal uncertainty about the possibilities left behind, an ocean of your own versions forever adrift beyond reach.